second. First thing, it's more of a review because we've been working on geological time, and which is basically the history of the Earth. There's a difference between the history of life and the history of Earth. History of life is also part of the history of Earth. So we hear the geological time scale. Open your books to page 334, chapter 10, section 6. 334 is the page. All right, when we begin talking about the history of Earth, you got a couple questions you see on the board?
Section 6, right?
Yes, ma'am. So we were talking about what is the geological time scale. Turn to page 338, and you'll look at what the geological time scale is. All right, we'll go back. You've seen it before, but we're going to break it down a little bit more. All right, the geological time scale just basically tells us how the Earth was formed and how it developed over the years, ranging from when it was just a ball of molten lava rock to today's world now. There are different kind of names for it. All right, they break it down into different divisions. You got the fossil record. All right, you have the fossil record. We've talked about fossils. We know the fossil can be created from bone, organic material, rock. You know what I mean? We all talked about that kind of stuff. So we're going to go a little bit in depth into that. All right, so we're talking about how they break down time, Earth's history. They start off with 4 groups called eons. All right, you don't have to remember this. I'm not going to test you on knowing eons, but there are 4 eons. All right, so you'll hear the term, like you may hear Bill Nye, or it's a term that some people use of like, you know, it's been eons since I've seen you. Well, it can't be literally, because eons are the largest chunks of time in Earth's history, right? But after you go from eons, all right, it breaks down into eras. Yes, sir?
What's the difference between figurative and literal?
Figurative and literal is, if I say figurative means I'm using imagination and metaphors or something like that. It's like literally means if I say jump off, or let's say if I say, you know, get out of here. Well, I'm being figurative. I don't mean literally get out.
So when
if I say, you know, let's say you're getting on my nerves and I have to call for assistance and I say get out of here. I mean it literally. Get out of here. You get my point? There's a difference between me joking. Figurative is jokingly sarcastic. Literal means I mean it. Yeah.
So when you said eons, it's figurative.
It's figurative language, exactly. All right. But if somebody in the science, like now we're talking eons, I don't mean figurative. I mean literal. All right. And you're talking billions and millions of years. All right. So if you break it down from eons to the next section, which they show more of on page 338 and to 340. It breaks down the eras, all right? The original, the name of the 4 eras, Precambrian time, you see it at the top of the page in yellow, and the next one in blue is called Paleozoic era, all right? You turn the page real quick, you see Mesozoic era in purple, look at the next one, Cenozoic era. Now, go back to the first page, 338. Precambrian time, no life, nothing on the planet but rock. If you look at it, it says geological events. What is a geological event? Geological events are major things that influence the development of the planet. An example of a geological event would be an asteroid hitting the planet and wiping out everything on the planet. That's an event. It hit the Earth, geological, it's Earth, and it causes a change of some sort. Now, it doesn't have to be something as extreme as something hitting the Earth. We have geological events on Earth all the time. What's one you can think of? What's one?
The tectonic plates moving.
Tectonic plates. When they move, what do they cause?
Earthquake.
Earthquake. That's a geological event. So if you remember a while ago, we read up something and we were talking about seismograph, vibrations. That's how they know. So when you see on TV and they're like an earthquake hit in Thailand and you'll see something like this, when you see it on the news, it'll be like this. And then they'll have a dot. Well, the dot is where they believe it started at, right? We talked about that before. The dot is the epicenter, right? Center. So what these represent are the waves stretching out, spreading out, right? So if so we talk about geological events. So when an earthquake hits, let's say we talked about the various ways that the plates move. So they could be converging or submerging. So this is one plate, this is another one, right? Now, if they're running into each other, and it moves an inch, maybe every year, what is that I'm hearing? Is that you? Turn it off.
It's his foot.
It's split?
His foot was on.
Oh, I didn't know what it was. Sounded like something else. I'm sorry. Anyway, they split, like they'll be like this, right? And it'll move just a little bit. But just a little bit of a tectonic plate is enough to destroy buildings, okay? Like, it doesn't seem like it much, because they'll tell you they move a little bit over less than an inch every year, right? And so that enough could cause an earthquake. So we're talking about geological events that change. We're also talking about what actually lived on the planet. The only thing alive on the planet at that point is bacteria, algae, small one-cell organisms, things like that, right? You see examples of them in the picture of jellyfish-like animals, things like that. So the next era, Paleozoic. Right? If you're looking at it, the Paleozoic era is when fish first hit the scene. All right? The world is pretty much covered in water for the most part. It's warm, shallow. It's not like deep like the oceans we have now. It's fairly shallow. And as you see, you have various things, brachiopods, but some kind of invertebrates. Like, invertebrates mean they don't have a spine. Like if you see, they have what would be considered arachnid. Another word for an arachnid in our world is what, do we know?
Spider.
Spider. So we see that it's in the Paleozoic period, the Paleozoic era, and the Silurian period, because it goes from eons to eras to periods. So they just keep breaking it down, section after section. Well, you see that spiders developed in 438 to 408 million years ago. Now for us as humans, it's hard as hell to even imagine that. It's hard to imagine 408 million years ago, right? Because we live for what, 40 to 100 years maybe, right? So the only way we can figure these things out is looking at fossil records, things like that, learning, having to figure out, you'll look at these in a moment, there'll be levels, you'll see it, and sediments. We talk about sedimentary rocks. Sedimentary rocks are rocks that gravel landed, compacted, somewhere gravel landed, compacted, so now you have 3-4 different levels of rock. You got your hand up, what's happening?
Why does the world look flat?
Oh, that's just how they draw it. Well, what you'll see is, if you're looking, you see the little globes, the little oval globes? We were just talking about plate tectonics, remember? What is plate tectonics? Plate tectonics, if you remember, is the crust moving, right? That's what we just talked about. When I said this, it's the earth moving, the surface of the earth. We know that the crust is the top of the earth, so it's the crust, it's the surface of the earth moving. So if you look, this is if you look under Cambrian, all right, that's what the earth looked like then. If you look to the next one, and it moved. You also have another one. You keep looking in the Permian on 339, it shows you another one. If you look on 340, it continues on until on 341 you see the earth as we live on it today. Now, without wasting too much more time on that, we're going to look at how life developed on the earth, came into the earth, all right? So, if you look on page 339, can somebody tell me the geological event that allowed us to have North America? Do you see it? It's in orange. The geological events are in orange.
Sea rise and fall.
Sea rise and fall over what is now North America. Where we lived at one point was completely underwater. Where we live, standing right now, at one point was nothing but water. Yes, Brady.
It says North America and Northern Europe lie in warm tropical regions.
Warm tropical regions. Right, so the climate, it's not just the land changes, the climate changed too. It went from warm to cold to warm, water here, no water there, over millions of years though. Like it's not one day you wake up and you're like, wait, my house is underwater. It happens gradually. So if it's happening, you know, if the life forms, what do you think happens as the water rises if you're on the land? What do you do if you're a landowner?
Migrate.
Migrate. You move where the water ain't coming. But you need water for food, right? So if you consider, remember, they also break it down. So when they break down time, they break it down from geological events to tell you how it affects, geological events tell us how it affected not only how the earth developed, but how life developed and changed. Okay? There's a reason why, let's say I take a piece of bread and I drop a little bit of water, just a drop, and I seal it in a plastic bag, and I put it in the closet, and I check it 20 days later. What do you think happens?
It's from mold.
In the closet?
Oh no, it's not mold.
It's gonna get moldy, right? Well, it's not gonna just mold just cause, mold will get on it if I leave it sitting out, but we've all seen stale bread before, right? It gets hard, but if I put it in the right climate in the closet, all of a sudden mold is exploding, right? It's growing like crazy. Well, it's the same type of thing when we're talking about what the geological events did. If something hits, raises the temperature, certain animals will survive, certain animals will not. Now, do we know what they say the oldest living species is? What?
Fish.
Nope. What do we think? What else? There's something right now that has a history older than fish.
Mammals.
Nope. Mammals we're the last ones to develop. Here's a hint. Mr. Williams has a whole bunch of them in his house. Exactly, Trey. Exactly. Yeah, because you know Mr. Williams. Yeah, thank you, Mr. Williams, for donating your house to the cause.
Before he even said that, I was going to say cockroaches.
Yeah, cockroaches, they're adaptable. They can deal with various climate changes, whether it be cold, whether it be hot, whether it be damp, whether it be dry. And those animals, another example is the shark. Sharks are old. Sharks are one of the oldest living creatures. And if you watch more, like I'm a guy who watches National Geographic, I'm always watching Shark Week, they'll tell you, sharks are the oldest living predators. All right? So, when you're talking about how life developed, now if you notice one thing, we're always taught, I ain't gonna say taught, as kids, we tend to believe what was the first living thing on earth. What do we usually think?
Ourselves?
Either us or what kind of animal? The kind of Jurassic Park, dinosaurs, right? When you think about the history of life on Earth, you tend to think dinosaurs were the first. Well, if you could look at the pictures, an example, this shows you right there. Dinosaurs didn't even come. We're talking 245 million years ago, and dinosaurs were not alive yet. Yes?
It says that plants could only live in water, and a plant that lived on Earth that could live on Earth.
Where are we looking? What page? Point to it.
338 on the Solarian.
Solarian, yes. Early continents collide with what is now North America. You're right. Now, coral reef, do we know what coral is?
Yeah, it's like a plant.
It's like a living underwater plant. All right? So plants were probably, algae is a type of plant / living organism. But plants are alive. So what we're seeing is the development went from the smallest, it was more like when you look at what's called the Precambrian time, it was, they describe it as almost soupy. The water and it was thick with animals and algae and all that kind of stuff. So they describe it as soupy and murky and hot, all right? But as the earth cools some, all right, we look to about 245 million years ago. Look on there, look at the section on the development of life, the final column, look in the green. Tell me what developed and happened 245 million years ago, or about them.
Reptiles become dominant on land.
Reptiles, do we remember what reptiles are? Give me an example of a reptile. Snake, give me another one.
Okay.
Lizard is an amphibian, close.
Alligator. Turtle.
Gator, turtle, exactly. Those were the ones that they move in. All of a sudden we have them moving in. Now they're not the same ones that we know, right? They're not the same ones, but that's what comes in. So let's switch to the next page.
I didn't even know that. I thought plants always lived on land.
There are plenty of plants that, you ever heard of seaweed? Live in water. So people eat seaweed for salads. If you go to a lot of coastal and what's called South Pacific places, it's like Japan, it's like Vietnam, places over there where they eat a lot of seafood because they're coastal and islanders. They have seaweed. You'll find all kinds of seaweed dishes. All right. So let's look at the Triassic period or the Mesozoic era. It says 245 to 208 million years ago. Now, do we know what this word means? What are they talking about? Because you're going to hear this word as long as you are taking historic Earth history classes. We know what that is? Nope. Good guess though. Pangea. Pangea, going back to what Trey brought up when he said, hey, what's up with those weird globes? Pangea is what they called when the entire Earth fit together, well, not Earth, the continents all fit together at one time.
Yeah.
And so it's called a supercontinent. Now, if you look, let me see if I can find it real quick. If you look at the Earth map on 341. You see it? If you look at South America, you see South America right there on the left side, the bottom?
Yeah.
And then you see Africa? You notice anything interesting about their shape? What does it look like?
Like they're together.
Like what? Like they fit like a what?
Puzzle.
That's what it is. It's one big, the continents and the crust tend to be one big puzzle. So when you hear the term Pangea, you're talking about the moment when the entire Earth, I keep saying Earth, the entire, all the continents were interlocked at one. Now, here's one thing about that. So if everything is all together at once, that means all the animals are together at once, right? All living creatures. Well, as, what do we say? It moves up slowly over time, right? As it spreads, what does that mean? This is how you end up having these kind of animals over here, and then you have these kind of animals on this continent, and you're like, well, you know, how are there deer in North America, but then they got the same kind of deer in Europe?
Because they split apart.
Because they split apart, and some of them stayed here. Then you have what was an ice bridge, right? At one point, there was what's called an ice bridge that went from Alaska to Russia. Millions and millions and millions of years ago. So, but this is during the Ice Age. That's how humans got here in a large part. They went from the ice, there's a large portion of people, Eskimos, Native Americans, that came across the top, meaning they crossed from northern Russia, a huge ice bridge that went into Alaska. And that's how they migrated on down to where we are now. Now, mind you, hold on, Brayden, I got you. Mind you, that's not how, there are disputes about how that works out. Is that the only way we could have been there? No. There's evidence that shows that there have been indigenous tribes and people that have traveled across the ocean to the United States and South America without that ice bridge or boats. So that's something you can look up later. You had a question?
You know how they were all together when they separated?
Yep.
I feel like they're gonna, eventually once they move, they're all gonna move back around the other side.
And come back together.
Come back together.
That's exactly how it works.
But then what? Are they gonna go in reverse again? Like to the other way or just keep crushing together?
It just depends on basically it depends on the Earth's move.
So what's making them move?
The lava. Remember, the crust is sitting, when we talk about plate tectonics, well, you weren't here. When we talk about plate tectonics, the plates are all moving. There's a ball of hardness called the core, and above it, and then finally you got the crust, where they're floating. The crust is floating on the mantle.
So
the mantle is mostly liquid.
Could it come back again?
Yes.
Oh.
Yes, it definitely could. So we're talking about the Mesozoic period, and that lets us know the start of what? What do we see started in the Mesozoic period? What do we see finally showed up? Look in the green. What do you see?
What? Creodonts.
Dinosaurs. That's when they show up, right? About 245 million years ago, they started showing up. Now, if you look at the bottom on the left, that looks like a velociraptor. See, what happens in Jurassic Park, what they mess up with, is they make us think all dinosaurs all lived together, all at the same time. Well, that's not how it went. You had certain ones that lived at an earlier period, then something happens, they disappear, then you have some other ones. For instance, if you look, it shows you right there, Tyrannosaurus Rex came out 144 to 66 million years ago. Well, the Diplodocus came out 208 to 144 million years
I
ago.
wonder what the mixture of dinosaur is a T-Rex.
Exactly. Wait, you said that's the only mixture, right?
Like I wonder what type of mixture of dinosaurs these dinosaurs are. That.
Now, the question, with that, I would, here's how it goes. Historically, what is the prime motivating factor for animals and life forms to adjust how they live or how they be? What is it? What are the type of things that, let's say we're humans, right? We're all people. Let's say, what would change, what things could change how we function? What could happen on the planet to change, make us have to change? What things could happen? What do we need? The atmosphere could change, right? Let's say it get too hot. Let's say it get way too hot. Well, we gotta figure out somewhere to go because we're human and we can only deal with certain temperatures, right? What if it get too cold? Well, we gotta find somewhere to go, right? Which also means, let's say we get an ice age here, right? And that means most of the land animals and stuff are gonna die, right? Because it's too cold. Well, what do we need to figure out what we're going to do, how we're gonna eat, right? Plus, we gotta find shelter. So that means we may have to go live in a cave, which means we're gonna have to change our diet. Well, if we live in a cave and there's no light, what do we need our eyes anymore? No. So what you find out is animals adapt based on their environment and the food supply and habitat. Those are the three things that determine, what they do and why. Well, obviously T-Rex lived in a world where he didn't really need his hands. That's why he got the little shorty, you know what I mean? That's why he got that. You basically get what you need as the world lets you have it. All right, so we move on. Almost done with the review part. And we move to the
I just noticed something.
What?
There's some theories that say humans evolved from apes or something, but on this scale it doesn't even show them on here.
Well, what does it show? It shows the development of mammals. So, you're right, they don't even talk about that. But make sure you understand something about school textbooks. They don't cover everything. They give you a general overview of certain topics. They don't tell you about everything. So, there's more to be read when you're talking about dealing with the history of humans and what we evolved from. All right? So that's what you see. You see the Cenozoic era, that's when we evolved. Mammals really take hold in the Cenozoic era, 66 billion years ago. Well, still again, we're talking about a long time ago, even though it's nowhere near the same length as, or as far back as Precambrian time. All right? So, knowing that, I'm gonna show you a couple of these rocks. You can come up here, please. Just walk. That way it's easier for you to look. Now, let's look at these. I'm gonna turn them around so I can remember which ones they are. All right. Now, remember I said that at one point North America was covered by a shallow sea, right? Ohio, I said, used to be a shallow sea. Lots of different creatures lived in the water. All right. Now we're looking to figure out bryozoans. That's this. It's hard for the if you're walking down the street and I'm just like, look at that, it just looks like a rock, right? To the untrained eye. But as you look around, you see little things within it, all right? These were living organisms. These were living organisms. Everything, look at that. These were living organisms. That was something alive in there. And then you see that line? That's what I was talking about when I say, hey, they separated. These were living organisms.
So that's obsidian?
Yeah. So, we're also talking about the crinoids. You see this? See the little circles?
Yeah.
It's not this. These circles are the fossils.
That's cool.
Right. Those are the fossils in there. Right? So then we're talking about, again, we got brachiopods and trilobites 250 million years ago. All right, now what did we say 250 million years ago is Paleozoic era, right? So, these are the trilobites in there, these little things like that, right? Trilobites, tri means three, so they used to walk with like 3 legs extra.
That looks like pyrite.
Yep, but it's a fossil of a trilobite. Then you have these, brachiopods. They look like seashells, but, you know,
There's a really good one.
yep, you can see it right there. There's another one, right? So basically, when you're talking about how they fossils form, pressure, they fall on top of each other, all right? We're still looking at the horned coral 250 million years ago. You can touch any of them if you want.
There's a lot.
Yeah.
You just find this anywhere?
It's like a shell.
Well, these were loaned to me by the science department, but yes, if you know where to look, yeah, because it is. It's dense.
It's heavier for a rock.
Then we have here, all right? Now you're looking at this one. This was a fossil formed by worm. Basically, they were worms. They're called boreholes, but they were formed like worm. Well, what you're seeing are the boreholes. They bored through, right? So animals created all of the.
Ant tunnels.
Yeah, but they were like worm creatures, and you can tell because look how long it is. Look how slim it is. Get it?
Yeah, because if
You touch it.
you look at an anthill, they make those things like inside a wasp nest. They have those tunnels.
Exactly. Now we're looking at here. All right. Again, this is going around my way. And just make sure you put them back wherever they start. Now here we have this. Now this is based in limestone. Limestone is a type of rock, obviously. But we also see our trilobites. All right. I circled them to make sure that they were easier to see. Now another one. Okay. And now again, I'm not gonna pretend that this is the funniest thing in the world to know, but when you really realize it, like, wait, that ain't just a rock. You never know. So if you find something, if you're out in another state, another country, another place, and you find something and you're like, I wonder, you never know what could be in here.
I thought all this stuff in here was just broken up. Wrong.
Right. It looked like just rocks, right?
Rocks we found out back.
Right. But, what were you asking?
So in this, you know, Marble Cliff Rock Quarry.
Yes.
So I've been there, and there's like so many fish because there are fishes in there. There's a lot, like you mentioned a lot, but I was gonna say it's really deep. So I think like there could be like stuff like this under there.
Probably.
I wouldn't go down.
Now this is called gneiss. All right. This is, 1.2 billion years old. This rock here,
Yeah.
you're looking at something that's 2 billion, almost 1.5 billion years old. This is how old this rock is. And you can see the layers, remember I talking about? So it would have been formed like this most likely. Yeah, you can touch it. All right, more than one type of gneiss is that part in there. So it's layers. Remember I told you those layers show? That's how and it compresses and that's how it comes together. All right, what else we have here? All right, cooling lava, volcanic glass.
That's really sharp.
Be careful with it and touch it if you want. Volcanic glass is passed around. All right, we have obsidian and pumice.
I found one. Oh, did you know about Old Man's Cave?
Mm-hmm.
Or Ash Cave?
See how light that is?
I was in the creek. I have a piece of this at home.
See how light it is?
But I was in this creek and I found this thing and it was like this.
Okay.
But some of it was really smooth. Like you could tell it was like a drop of like lava. I still,
Right.
I can still.
See what happens with lava when it cools? A lot of time, see how light that is? Look at that.
Mr.
Yeah, these are all lava.
I feel like that.
I kind of have
They
some.
it's hard to describe it. The minerals, that depends on where it's at, the minerals determines what minerals it is.
Well, that's light and weird.
So like you see all the bubbles from where the air pockets popped?
So that's the lava.
Yep, that's lava too.
But I have a lot of quartz in my room. I
nice.
have like geos. I have one that's like this big, my biggest one. And
Okay.
I have a shelf for all these.
Okay, so we got another web
Looks
question.
like, it looks like little pieces of dust.
Right, and you notice how if I rub it, it breaks. You gotta be careful with it because it's just like you said, it does. All right, so we're gonna do this web quest. Oh, I gave you wrong one. Google, we'll type in geological time scale web quest. And once you type it in, you should be at the first. It should be the first link. No, it's it's not, this one isn't very difficult. You should be able to get through it. As you see, it's basically fill in blanks, and then you have a quiz at the end. Make sure you put your name and the date on it, please. First name, last name, please. Write your name and date on it, Brady. Need a pencil? I got you. You got the sharpness, young man.
You literally want to search WebQuest?
Yep, geological time scale web quest. And it'll show you the link that you're supposed to go to.
Dang, that's a good impression. Did you go to art school? Mr. Gibbs, you're
Yes.
probably for that.
All right, when you get there, you click on Geologic Time, University of California, Museum of Paleontology. See? Time scale. What is? One word. That's fine.
This is the first one right here.
Right there. Okay, here we go. Right there, the first one. Yep, first one. University of California, Paleontology. Now, the answers are just like, now you read over it. Let's go over it. Question 1, it says, now put them.
The Earth.
You don't have to wait for me. I just want to make sure I read the question for you. So I'm sure that you understand what it's
I
asking
think
you.
I'm the wrong one because it says I'm on a game.
Let me come look. No, you're fine.
This is it?
That's it. Remember, you got front and back on the sheet. Make sure you got front and back. It goes up to number 10. You have front and back. You take this one. Front and back. I gave you my original. I'm sorry. Here, take this one.
This one. How do we find the answers to this?
Did you read first question 1?
Oh,
Then
okay.
it goes to number one.
It just tells me.
If you read the question and we look at the screen, we can find our answers. It's fairly easy for you, and it tells you what to do.
Hit play again.
Yep, you can go next, or you can play it. It's up to you. Did we all get number 1? The Earth has a blank. And long. What is it?
Earth.
All right, did you write it in? Number 1 is Earth.
Yeah.
Who can tell me how old the Earth is? Is that what it said? There you go.
Do you understand? I don't get this. Because it has all this, but then it says this is 3, this is 4, this is 5, this is 6.
These are part of this question. What happened then? What happened
So I
then?
need to go back.
No, you go more. See what it says.
Oh, you gotta keep playing more.
Who?
I don't know why it's not functioning. See? Click on it. Right here. See?
Okay.
You get it now?
Yeah.
You click on the pinks and the red, and that's how you flip forward. So if this one, that's the answer for there. Get it?
Okay.
Early land plants. That's when they arrive. Okay?
How we find that out?
Hold on, I got you. Okay, so when you get on this page, it says click on more. Then I click on this. What I did, more.
So, this one right here, the formation of Earth and Moon.
Hold on, let me help him real quick. So it says 4.6 billion years ago, what happened? Click that, man, formation of the Earth and Moon. Let me write that there. Get my thing.
This is the right one.
That is the right one. So then we go here. See where it says more, because you have to read. Remember, you have to read first. All right? Click there. Read some more. Even if you were an amazing speed reader and can read 2 pages every second, it will still take you nearly 73 years to read the entire book. Let's make a bit more manageable. So they basically show you how to condense it. They're talking about how old the Earth is.
Ain't this Earth?
So, now, we're in this section, and it says what happened 4.6 billion. How do I find out? I click on the cards. So I click this card, 4.6 billion years ago, it was the formation of the Earth and Moon, and I write that there. When I'm done, I click done, then I go to the next colored card.
This is not right.
Which one?
This one.
3.9, this one is this. That's when the earliest life forms showed up. So you're right, earliest life showed up. Got it?
Oh, that's really her name, Lucy.
No, that's what the name they gave her.
Oh, I've seen this before.
All right, so here's what we're going to do, because we're nearing the end of the period, so we will get back to this. All right? We'll get back to this. You can work on it during lunch if you want, or you can work on it during Monday when we get back to enrichment time. You can continue on working until the end of the period. Very good job today. All right? I'll put your books up for you.
Wait, so class is over?
Well, you know, I'm getting out of here in a second. Silly.
Mr. Gibbs. Mr. Gibbs.
Hold on.
He's on here, that's the certificate.